What's going on, guys? Welcome back. Hope you are doing well. In this module, we're going to be covering something called conditional programming. And what it is essentially just a decision-making process that we can implement within our programs. So it's going to allow us to execute certain pieces of functionality under certain conditions, right? And this is something that we actually do in our everyday lives every single time we make basic decisions, right? For example, you might ask yourself, is it cold outside? Yes, put a hoodie on. If it's not, I can wear t-shirts and shorts, right? Or am I tired? Yes, go to sleep. No, keep watching Netflix, right? So we're just going to go over how to implement that kind of functionality programmatically and then go through some examples of how we might use that in real life applications. So to get this video started, let's just go ahead and check out a brief overview of this stuff, give you guys some visualizations of how this works before we get started with the code. So once again, guys, conditional programming just allows us to execute certain pieces of code under certain conditions. So I want to just show you a visual diagram of what this decision-making process looks like, right? And once again, it's something that we do every day in our day-to-day life. So for example, are you tired? Yes, then you could just go to bed. If you're not, you might keep watching Netflix, right? So basically, based on whether or not this condition is true or false, this am I tired guy, we are going to execute a certain piece of functionality, right? So if we are tired, we go down this path. Yes, go to bed. If not, then we just keep watching Netflix. So before we jump into Xcode and actually implement an example on our own, let's take a look at what this is going to look like programmatically. So I have a code snapshot up of what this would actually look like in a program, guys. So let's imagine we have some Boolean variable called sleepy, and right now it's equal to true. So basically what this is saying in plain English is, hey, if you're sleepy, print go to bed. If you're not, watch one more episode. So let's break this down a little bit further. We have this if keyword here. So this means that our compiler or our program is going to check to see if something is true or false. And then if that thing is true, which is what we're doing here with our comparison operator, we're checking to see if sleepy is equal to true, then we're going to print go to bed. If sleepy is false, then we would print watch one more episode. So this is just a programmatic representation of that decision tree diagram that we saw in the last slide, guys. If this condition is true, then we go down this path, we execute this piece of code. If it is false, we execute this piece of code. So if we had changed sleepy to false, it would skip the if block and it would jump straight to the else block because it would say, hey, you're not sleepy, so you're going to watch one more episode. So it's important to understand that both of these pieces of code cannot get executed, right? We're creating a path and our program has to choose a path to go down. And it is based on whether or not this condition is true or false. So that's just a brief introduction to how this stuff is going to work and what it's going to look like in the code, guys. We're going to hop into Xcode now to do a bunch of examples and really get some practice with this stuff so that it starts to make more sense and you can see how it's going to be applied in real life programs or applications. So let's go ahead and hop into Xcode now and get started with the code. So to start this off, we are going to create a new playground. So let's hop over here and right click on our project file name. Hit new file, and we are going to search for a blank playground, hit next, and we're going to call this control flow, guys. So this is just another way of describing what we're doing here. We're controlling the flow of our program through the use of these if-else statements or logic gates as they're referred to sometimes. So we're going to start off with a really simple example. And we're just going to break it down piece by piece. There's a couple little nuances that I want to cover in terms of the brackets and how to type this out before we move forward with some more complex examples. So we're going to start off by creating two variables, A and B. We're going to set A equal to 2 and B equal to 3. So what we're going to do is just write a simple program here to check and see if they're equal to each other. And we're going to give back some sort of message or print out some sort of message to give us back the result of whether or not they're equal. So we're just going to say if, and you guys will once again notice that this is a keyword that my compiler recognizes. Now we need to follow this with some sort of condition. So we want to check and see if A and B are equal to each other. So in order to do that, we would say A equals B. And then after that, you're going to open up this curly bracket, guys. And then once you hit enter, your compiler will close out that curly bracket for you. So this is what's known as our if block. So if you guys remember from the overview that we did, this is only going to get executed if this condition is true. So the code we put inside of this if block will get executed if this guy is true. It will go down this path. And then if it's not true, we say else, and we will refer to this as the else block. And whatever code is inside these two brackets will get executed if this condition is not true. And if you guys want to see where one bracket ends, like if you want to see, hey, where does this bracket end? You can just double click on one of your brackets and it will show you where the ending bracket is. So you can see that full block of code. You could imagine if your code starts, if the block is like really long, it would be helpful to be able to see where it ends and everything that's inside that block. So that's just a cool little tip. So basically, guys, all we're going to do is say print A is equal to B. And else, we're just going to print A is not equal to B. And then if you go ahead and run your program by clicking that play button, we're going to get A is not equal to B. So if I went like below my two variable declarations and I said A equals B, you guys will notice that the updated value is now 3. The updated value of A is now 3 because we set A equal to B, and then it gives me back A is equal to B here. So once again, guys, we notice that only one of these blocks can be executed, and that is the point of this control flow here, right? Because we want to force our program to only go down a single path. We're creating like a fork in the road, and it has to pick one or the other. And that is all based on this condition here. And we typically use comparison operators to create these conditions. So really quickly, I'm actually going to paste our notes up here for this module. You guys should pause the video and type this out. So we see here that conditional statements allow us to execute certain blocks of code based on whether or not a given condition is true or false. And we typically use comparison operators for this. So you guys could write all kinds of conditions here. You could say is A greater than or equal to B, is A greater than B, is A less than B, and you could add the corresponding print statements for those results. So that's just a really simple example, guys, of how to use comparison operators to implement a simple if-else statement. So now what I want us to do is implement a Boolean variable like we did with our sleepy guy and going to bed or continuing to watch Netflix. So let's go ahead and create another variable up at the top. We're going to say var sleepy equals true. And we're just going to write out that if statement that we saw in our presentation. Just once again, get some more practice with typing this stuff out and familiarizing ourselves with this. So we're going to say if sleepy, and you can open up your curly brackets. And yes, we do not necessarily have to say equal equals true there. I will explain why in a second. And then we can say else and open up your brackets there. So here we're just going to print go to bed. And here we can print watch one more episode. And let's run this. And we'll notice that we get go to bed. So you guys might be asking yourselves, hey, why didn't you have to use this equal equals true guy to check if sleepy is equal to true? Well, basically, Swift is smart enough to know that we're checking to see if a Boolean variable is true or false. So it basically handles this for you. So you don't have to type it out with Boolean variables, right? Because Boolean variables can only have one of two potential values. So if you're just saying, hey, if sleepy, it's basically saying if sleepy is true. So you don't have to type out that equal equals true guy for Boolean variables. So really quickly, guys, if we change sleepy to false, I got to say sleepy equals false, and rerun our program, we'll notice that it prints out watch one more episode. So just another example of how to use Boolean variables within if statements. And really quick, guys, I just want to touch on this equal equal sign one more time. This is something that beginners get confused with all the time. And they confuse the single equal sign with the double equal sign. So I just want you guys to remember that the single equal sign is an assignment operator. It sets something equal to something else. This is setting A equal to 2. This is setting B equal to 3. And on line 13 here, we're setting A equal to B, right? But with two equal signs, every time you guys see that, I want you to say in your head, is equal to. Okay, so when you see two equal signs, you say if A is equal to B. When you see a single equal sign, you say, hey, I'm setting A equal to 2. I'm setting B equal to 3. I'm setting sleepy equal to true. Or here I'm setting A equal to B. That is very important to understand early on in your programming journey, because like I said, it's something that people get confused with all the time. So just wanted to touch on that. But anyway, guys, let's go ahead and do a slightly more complex example. We can definitely go through some examples of how to make our logic a little bit more complex and a little bit more functional here. So I want us to create a variable called age, and it's going to equal 18. So we are just going to start this off as a very simple if-else statement. Oops, I need to say var age equals 18. Sorry about that. So we're just going to say if age is greater than or equal to 18, print you're an adult. Else print you're a minor. So this is a very simple age checker, right? So if we run our program, we'll notice that we get you're an adult. If I changed my age to 16 and ran it, it would say you're a minor, okay? So I want us to make this a little bit more complex. So basically, what if we wanted to add another sort of pathway here, right? We wanted to check if someone is older than 18, but what if they're older than 65 and that makes them a senior citizen, right? So what you can do is you can actually add something called else if statements. So I could say if and then else if age is greater than or equal to 65, print you're a senior citizen. And let's move this back up here. So this is just showing you an example of how you can introduce multiple pathways into your control flow. So you can say if, else if, else if, else if. You can sort of have an unlimited amount of else if statements, right? Just to introduce more pathways into your logic based on whatever the needs of your program are. So here we're just trying to determine if someone is an adult, if they're a minor, or they're a senior citizen. So something interesting here, guys, which is why I love this example so much, is that this is actually just going to print you're an adult. Oh, sorry, we got to change this back to 18. Or let's actually change it to 65. So we'll notice that this just prints you're an adult, right? So you might think, hey, it should hit this else if block. But once it goes and hits the first if statement, it says, hey, age is 65 and 65 is greater than or equal to 18. So I'm just going to print you're an adult. And then once it hits a particular block or goes down a particular path, it completely ignores all of the other paths. So you might be asking yourself, okay, well, how do we fix this? Well, the simple answer is you would just want to check to see if they're 65 first, and then check to see if they're 18, and then hit your else block and say, hey, everything else is means you're a minor. So if I change these two ages, 65 and 18, you guys would notice that it prints out. Oh, let's switch these print statements up. And I'm going to show you guys a detailed diagram of this to just make more sense of it and help you visualize it in just a second. I just want to get the program working first. So when age is 65, it says you're a senior citizen. If I change age back to let's say 50, it's going to say you're an adult. And then if I change age to 15, it will say you're a minor. So really quickly, I just want to show you guys a visual breakdown of that so you have a better understanding of how this is working, and we can come back to the code and do some more examples. Okay, guys, so when our code looked like this, age was 65, but we first only checked to see if the user was greater than or 18, we noticed that it just printed out that you're an adult, but we wanted it to print out that you're a senior citizen. And here's why. This is what the visual breakdown of this would look like. So first off, our main condition is we're checking to see if they're over 18. And the age is 65. So 65 is greater than or equal to 18. So it just went down this path and printed out you're an adult. And it completely ignores all of the other paths. So if it was no, then it would ask if the user was 65 and then say, okay, you're 65, you're a senior citizen. No, you're a minor. So we had to just reorganize our if statement to look like this. So we first check to see if they're over 65, and then we print they're a senior citizen, and then we check to see if they're over 18. So this is what the updated path would look like. Hey, is the age greater than or equal to 65? Yes. Okay, you're a senior citizen. And you guys noticed if we changed the age back to like anything below 65, then it went down the no path, right? And then it checked to see if they were greater than or equal to 18, and then it would print yes, you're an adult. If not, then it would ultimately print no, you're a minor. So that's just a really good example to show you how you can implement multiple pathways in your control flow and how to do it so that you get the correct result, right? You have to think about the first condition that you check. And it's also important to illustrate the concept that once we go down a particular path, it ignores all of the other paths and sort of exits this control flow statement. So let's hop back into Xcode and just do a couple more examples, guys, to really cement our understanding of this stuff. So in this next example, I want us to introduce the concept of logical operators. So what these are going to allow us to do is create compound logical expressions. So what I mean by that is up until this point, we have only been able to check to see if a single condition is true. A logical operator is going to allow us to create a combination of things to check to see if multiple things can be true at once before we execute a certain piece of code. So really quickly, guys, let's just go ahead and do an example to see what the heck I'm talking about. So let's imagine you're trying to write a program to help you figure out if it's a good idea to buy a car or not, or if you're even able to buy the car. So we're going to introduce a couple variables. We're going to look at how much cash we have in the bank, what the price of the car is, and what the current interest rates are. And we can write a program to help us determine if it's a good idea to buy the car or not. So let's go ahead and introduce these variables, and we're going to implement some logical operators into our control flow here to illustrate what I'm talking about in terms of what these are. So we're going to say var total cash, and let's say you got 50 grand. You're balling, right? And then let's say var price of car equals like, maybe let's make it 40,000. And then let's say var interest rate equals like 0.8. So that's an 8% interest rate. Okay, so let's really quickly just write a simple program here to see if we can afford this car. So basically I could say if total cash is greater than or equal to price of car, and to create this compound expression, guys, this is where this comes in. You're going to implement two ampersand symbols or two and symbols here. So this is going to allow us to check to see if something else is true before we go down this or enter into this if block. And then we could say interest rate is less than or equal to 0.6. Print buy the car. Else print you can't afford it yet, save more money. Right? So basically, we're checking to see if one, we have enough money to buy the car, but two, we only want our interest rate to be less than or equal to 6%. So currently, you guys should be able to ascertain that this would print you can't afford it yet because the interest rate is greater than 6%. So let's print this out or run our program. It says you can't afford it yet. You need to save more money. But if we were to change the interest rate to like 0.5, it would say buy the car. So basically, guys, what we did here was introduce this logical operator here. And this is what's known as an and condition. So if you imagine that this piece of logic here is condition A, and this piece of logic here is condition B, both A and B have to be true in order for this if block to execute. So we also have an or condition that we can use. So I could say two up and down lines like this, and you guys could just hold the shift key and hit the backslash button, I believe it is, or /, one of the two, you'll find it. But basically this would say if this is A and this is B, only one of the things has to be true in order for my entire expression to evaluate to true. So you guys would notice if I change this back to like 0.1, meaning like a 10% interest rate or 8 for 8%, and I ran my code, it would say, hey, you can still buy the car because you have more cash. So in order for an or statement to evaluate to false, both A and B have to be false. So if I change the price of the car to $60,000 and the interest rate was 8%, it would say, hey, you can't afford this yet. So I'm just going to bring up a quick table here for you guys to see exactly what this looks like. So let me make this bigger for you. So basically, guys, if you have A and B, in order for A and B to be true, both things have to be true. You notice if A is true and B is false, then the condition evaluates to false. But A or B still evaluates to true. And then if A is false and B is true, this is false, but A or B is still true because one of the things is true. And then the only way that A or B evaluates to false is if both A and B is false. And then we have the not logical operator as well. So here, it's just the opposite of whatever A is in this case. So if A is true, then not A is false, obviously, right? So let's just do one more example here, guys, to really cement our understanding of this stuff. So, and then we're gonna, that'll be it for this video. So let's imagine that you have a tired and hungry girlfriend, right? You're in trouble here. So let's make two Boolean properties for that. So we could say var girlfriend is hungry equals true, and var girlfriend is tired equals true. So we want to write a program to see how much trouble we're in with our girlfriend. Okay, so we're going to say if girlfriend is tired and girlfriend is hungry, then your life might look something like this. All I want is Wingstop!
That's a little accepting.
I'm fucking starving, Swin! What did you eat today? I ate nothing! Nothing!
So yeah, that would be really bad. Really bad. So we're going to go ahead here and we're just going to say print state of emergency. Everybody run for their lives because you're in danger. Okay, you're in serious danger there. And else we can just say print you're okay for now. For now. So if we run this program, guys, we're going to notice that we're in a state of emergency and that everybody should run for their lives and be very afraid because someone has a tired and hungry girlfriend. So let's think about it like this. If we make girlfriend is hungry, we could consider that to be condition A and girlfriend is tired to be condition B. So this gets treated as like a single expression now. It's just a compound expression. So in order for this to be true, both A and B have to be true. So if I make one of them false, you guys will notice that we're okay for now, right? It hits the else block because in order for this expression to evaluate to true, both A and B have to be true. If either one of them is false, this expression evaluates to false and it ultimately reroutes our program into the else block or else path. So if I had changed this to or, only one of A or B has to be true. Either A or B can be true in order for this overall expression to evaluate the true and ultimately hit my if block. So if I run this now, you guys are going to notice that once again, we should run for our lives. So I guess it really just depends on how your girlfriend is when she's hungry or tired. So these are just some examples to show you guys how we can use logical operators to create compound expressions and introduce some more complex logic into our programs. And that's going to wrap it up for this video, guys, on control flow. Hope you enjoyed it. We'll see you in the next one. Thanks so much for watching. Peace out.